Our next question is question number 9. And question number 9 says that there is an electronic assembly that consists of two subsystems, say A and B. And from the previous results, uh, it shows that the probability of A failing is 0.2. So probability of A fails means that either the B has failed or it can be that B has not failed. So it just says that A has failed. It's not that A has failed alone. So probability of A failing is 0.2 and probability of B failing alone, that means the A is working is 0.15 and both have failed is 0.05. So we have to find the probability of this. So regarding these, let's say this is the probability that A has failed and this is the probability that B has failed and this is the probability that both has failed. And now because we have to find this, so this says that we have to find the probability of A fails and when B has already failed. So this is the probability of A and B both failing. And this one is the probability of A fails alone. Let me just draw it once again. Let me just draw it here. So let's say this is the probability of A's failure and this is the probability of B's failure. And this one is the probability of A and B's failing. And this one alone, leaving this one, this is the probability of, because this is A and this is B, so this is the probability of B fails alone. And if we take this completely, this one, this is the probability of B failure. This one is the probability of B fails, and this one is the probability of B failing alone. And in this case, this one is the probability of A fails alone. This one. Okay, now moving on to this one, it says that we have to find out probability of A fails when B has failed. So using the condition probability, it should be probability of A and B fail divided by probability of B fail. So this one we know the value of this, but we don't know the value for this B fail. And we are going to get this, but we are given that the B fails alone is given. So we know that if we have to find this is the B fails alone. So we have to, the B fails alone is uh, so this is B fails alone. This value can be calculated by subtracting it from B fails minus probability of A and B fails. So this complete is the probability of B fail, and this one is the probability of B and A fail, and this one, excluding this one is the probability of B fails alone. So B fails alone is 0.15 and probability of B fail, we don't know that. So it's probability of B fail, we don't know that, and we know this one as well, it's 0.15. So now the probability that B has failed is 0.15 plus 0.15, that's 0.30. And if you put in the value here, that solves our part 1. So A and B fail is 0.15, it's 0.30. which gives 15 by 30. That should be equal to 1 by 2. So our answer for the first part is 1 by 2. So this one is solved and it's 1 by 2. Let's move on to B fails. P of probability of A fails low. So probability of A fails alone is probability of A fails minus probability of A and B fails. So probability of A fails is given is 0.2. It's 0.2 minus 0.15. So which gives us 0.05. So our answer for the second part is 0.05. So that's also question number 9 for miscellaneous chapter 13. Thank you for watching.